Hello, everyone. My name is Eric Sondy, and I'm pleased to be here today with my colleague Jason Andrews for our second ARM-IP Explorer webinar. Here, Jason will demonstrate how to use ARM-IP Explorer to run simulations of your own custom benchmarks on ARM CPUs from your browser on configurable systems based on Verilog simulations of ARM-IP. He'll go in depth on how to set up and run simulations of ARM CPUs, how to understand your simulation results, and how to run simulations with your own custom software to understand exactly how your benchmarks perform on ARM IP. But first, a brief reminder of what ARM IP Explorer is in case you might have missed our first webinar. ARM IP Explorer is a new cloud-based SoC development solution from ARM, created to accelerate IP selection and SoC design, helping SoC architects explore, design, and share. With ARM IP Explorer, you can increase efficiency and productivity, getting started quickly with easy access to all the information you need, all in one place. Our streamlined web-based design tools simplify SoC architecture definition, IP configuration, and compatibility checking, and that leads to better design quality earlier in your process. More efficient collaboration with ARM, ARM-approved design partners, and other experts, along with the ability to easily export the artifacts of your design process, like IP lists, system diagrams, and simulation results, can all greatly reduce your cost and time to market. Now, in case you missed our first ARM IP Explorer webinar back in February, you can check it out on demand on YouTube or on the ARM events page. There you'll get a complete tour of the platform from Jason, including all of the capabilities that you see listed here. But today, we're going to go deeper and focus on one of the most powerful features of ARM IP Explorer, simulation. Simulate gives SoC architects immediate access to run simulations using industry standard benchmarks or even their own workloads right on the platform without any additional modeling or tools, saving weeks or even months of expensive and complex IP evaluation work. Now over to Jason Andrews for a demonstration of simulating ARM CPUs with custom benchmarks on ARM IP Explorer.
Hi everyone, I'm Jason Andrews and I'm excited to share more about IP Explorer with you today. So IP Explorer is a web application that helps SoC architects make IP selection choices. And previously I shared a tour of IP Explorer, which provided an overview of the platform. We ran around all the different features and kind of showed you a top level view of how everything worked. If you missed that one, you can go back and find it either on BrightTalk or on YouTube and watch that. If you haven't seen it, you might want to do this if IP Explorer is new to you. But today what we're going to do is talk more about the simulation feature. So simulation is one of the most popular features, and lots of architects and software developers use simulation to compare and contrast ARM processors by running custom software or benchmarks to try to figure out the performance analysis as they make their IP selection choices. So today what I'm going to do is walk you through how to create those custom applications and how to upload them into IP Explorer, run them with the simulation feature, and then view the results. So as a quick reminder before we get started, you can reach IP Explorer from our developer website, that's developer.arm.com. Or if you go directly to ipexplorer.arm.com, you can get to it there and you log into IP Explorer using your ARM account. If you don't have an ARM account, you can get one of those from the developer website. And if by chance you get to the ipexplorer.arm.com, and you're met with a form asking you to request access, you can go ahead and fill that in, and then somebody will look at the forms and grant you the access. Okay, so with that, let's get started with the simulation feature, and we'll talk through it and how you can make your own custom benchmarks for the simulation. So I'm here on the home screen of IP Explorer. In the top right, you'll see there's a simulate IP, so we'll just jump over there, and I'll give you an idea of how this works. So there's really two things to select at the top. One is going to be the project. So that's going to be the project that your results will be associated with and saved with. And then there's the systems that you can select. So there's a number of systems here that you can simulate. You can pick any of those systems, and then that's really the hardware, kind of the hardware design that you're going to run. And then down below is where the software comes in. Now, there's a number of precompiled or pre-provided benchmarks. If you just do the drop down here, you'll see there's a Drystone and Cormark and so on. And then there's a My Uploads tab, which is what we're going to focus on today, and how you can get your custom benchmarks onto the platform and run those with the simulation feature. Okay, so in terms of prerequisites, I've made a GitHub page here, which is really just a simple README file that you can use to kind of review the instructions. And I'm going to use this to go through the steps, and then we can share it, and then you can go through it if you want to look back and see what the steps were. Now, there's maybe one more prerequisite would be about the compiler. So you don't have to actually compile your code in advance. IP Explorer has compiler service built in, and it will compile your benchmarks. But I just think it's better to have a local compiler in case you make any mistakes or you need to make corrections. It takes longer to upload and then see, oh, there's a mistake, and then upload again. Of course, if you don't make any mistakes, it's no problem. But if you're like me, you might, and it might be easier to just make them on your local machine. So GNU compiler is what I'm going to use today, GCC. ARM-None EABI is the executable. I put the steps for doing that on Ubuntu or Debian Linux distribution, but it's easy to find for any other kind of operating system, any other machines. Okay, so the general flow here is going to be that we're going to download a software package, which is like a template with all the benchmarks and the makefiles and scripts and so on. And then we can add applications to it, check that they work with the local compile, and then upload them back to IP Explorer and run those on the simulation feature. So the first step is, well, we have to get into IP Explorer, which we've done, and then we need to go get that software package, which will help us to create the benchmark. So that's this button here, download software. There's another way to get to it, is if you click the My Uploads, you can also get to that place as well. Okay, so if you do My Uploads and then upload software, you'll see it says get boot code here, and there's a download .tgz file. So either way works, they're both fine. And so that's what we can do to download the software and get going. Okay, so let's just say we're thinking maybe about M33 in this case. And then we'll scroll down and do download software. Okay, so you'll see on my browser, there's a file called usersoftware.tgz, which is downloaded. And then I'm going to start working with that. And I'm going to do it primarily through VS Code. Just so we can see the source code and navigate the hierarchy a little better. So first, I will just copy that downloads file, user software here, over to an empty directory, and then I'm going to extract it with the tar command here, and then it will expand the files. So what we get is a hierarchy of files. There's a few things to take note of first. One is going to be the README file. So this is kind of your documentation to start looking at the package and what's all in there and what you need to do. So first of all, I'm going to change directory into that benchmark package. And then what you'll see is applications directory, which has those pre-existing or pre-compiled applications that you saw on the platform. So that's going to be super important. The other one, which is going to be quite important, is the systems directory. Now, the systems directory is not actually the systems themselves, but it's like the software support that you need for a particular system. So if I just open up one of the systems, you'll see there's source code for the different benchmarks that's necessary, and the kind of the low-level boot code and the scatter files and linker scripts and so on. So it's like a software support for the actual system itself. So if you look at the applications, like if you just take the hello world, it doesn't really know much about the detail of the hardware. So then we kind of separate that into the systems directory. And then when you go to link or build that application for a particular system, it will go get those other files related to that system and use it to match up the memory map and the compiler switches and so on. Okay, so let's jump back to the README here. So we've downloaded the file, we've extracted the package. One of the first things we can do is just compile an application to get a little practice for how it works. So there's a build script, build app.sh, and you give it the name of the benchmark, the hardware system you're targeting, and then the compiler choice. So this is GCC or ARM compiler for embedded. Either one will work. So I'm just going to copy that back and then come here. So you'll see there in the directory, there's a build app right there. And then we'll hit that, and then it will compile the benchmark. So essentially what that's done is compiled Hello World for the Cortex M0 Plus and create the executable that we would need to run that. Okay, so if we just do a find, let's just do hello.axf, and you'll see it's now in the applications directory. There's hello compiled for GCC, and there's a AXF, which is there. So that shows our compiler is working. We're able to run the compile script. Everything is fine. Okay, so now what we want to do is think about making our own application, right? So we made the first application, but let's try to make a new one. So what we're going to do is make a new application called FP Multiply. And the way we can do this is by copying a template. So inside the package, there's a template application that we can use to build on and modify. So I'm going to copy that template over to a new name, which is FP Multiply. And then I'm going to move the main.c file over to a new name, which is FP Multiply.c. Okay. So now what we have here is a new application. It's just called FP Multiply, and it's kind of blank, right? It doesn't say anything, but it gives you the structure and the skeleton to work from when you want to create your own application. Okay, so now the next thing we need to do is kind of configure the new application so that when we upload to IP Explorer, it will know the important parameters like the name of it and which compilers you want it to run with and the names of the hardware systems. And that's here. So there's a file softwareoptions.json where you set up these things. And then that will give you the name of the application. You can put in a description, compilers, and system. So I'm going to copy that here. And if we find that file on the top, SW options, you'll see it's there's a template in there and it's kind of got some blank stuff. So I'm going to copy a new version and delete the old stuff. And then you'll see it's configured as FP Multiply as the application. And it gives the description, compilers, and the systems. So that's in place. So we don't really need that now, but that's going to be of importance when we go and upload the software onto the IP Explorer platform. So now we need a benchmark. So for this case, we can fill in the main function from the template and we could do something else. You'll probably want to start small here and just maybe make some small improvements and then start building up your benchmarks yourself. So you can add extra C files, maybe some header files, change the make setup as you need to. But for today, we're just going to kind of take this main and put that in place of the one that was already there. So if we looked at the FP Multiply, you see it had some stuff here. So, well, let's just patch in the important parts, which is going to be the main. So I'll delete the old one from the template and then save that. So this is just a small program to multiply two floating point numbers and then print the product. So it just shows you how to customize the application as a new benchmark. Okay, so now what we want to do is check if we can compile that benchmark here. So again, we can use the buildapp.sh again, and then now we're going to give the new name because it's called FP Multiply, and we can do it for the same system, the M0 Plus with GCC. So I'll do that, and then you'll see from the instructions, it should create an AXF file, which is going to be in this applications directory. Okay, so let's run the build again, and then you see it compiles and everything is of course fine. So this is really, you know, a local check. So if I did make some mistakes here, I had some typos, it would be easier to kind of iterate here rather than, you know, upload it to IP Explorer and then get back an error log and iterate that way. Okay, so we have a benchmark which is functioning. Now I put a note here about the cloud compilation. So sometimes users ask, well, do I have to upload my source code into IP Explorer, or is there some other way I can just upload the binaries? And there's a way you can upload only binaries. And I would say the best thing is to look at the README file, but there's a value you can put in that JSON file, which is saying cloud compilation. And then that will basically let IP Explorer know that you don't really want to upload your source code and you're perfectly happy to just upload the binaries. So if you go down through the README here, it will explain that and how to use that cloud compilation flag so you don't have to upload any source code. Okay, for this case, we don't really mind to share the source code, so we'll go ahead and do that. Now the next step is there's a checker available called app checker. It's a Python script, which will kind of make sure that your application is in good working order. So it's kind of a structural check to make sure your JSON file is good, your source code is there, and some other checks so that when you do go to upload it, you don't want to face any errors in that case. So we just do ls here, we'll see that the app checker is there, and then we'll just run it, and then it's going to check out what it finds. Okay, so it's basically going through our software, our JSON file, and saying, okay, I can see you have an application called FP Multiply. It should work with ARM compiler 6. It should work with GCC, and it looks like the systems is all in order. So that gives us a check that everything is fine that way. So now what we have to do is really package the application and then upload it to IP Explorer. So how we're going to do that again is with a tar command. So we're going to pack it all up and the whole tree, so the benchmark package directory, and it's going to be called custom software. So you can name it whatever you want in this case, but I'll just do it as custom software. So I need to back up one. So you'll see the benchmark package is there, and then I'll run the tar command and it will pack up the whole thing. So when I'm all done there, you'll see now I have custom software .tgz, which is available. Okay, so if we go back to IP Explorer now, that's really what we want to submit. So if we go to the My Uploads and then we click on the upload software, this is where we can put it. Now there's two ways to upload your software here. There's one way, which is just to upload the tar file that we made. So I'll do that first. So I'll push browse and go into my directory where we're working and select the custom software and open that one. And then when I push the yellow upload here, it's gonna do that. The other one is to generate a command line command. So that will allow us to work from the command line rather than upload through the browser. So depending on your environment, if the browser is not easy to get to, or you're on a remote machine, something like that, that might be a good idea to do. But for now, I'm just going to upload the custom software, and then we will wait for it to go. So essentially it's going to upload the file here, and then it's going to read the JSON file that we talked about. It's going to go ahead and analyze that, and then it's going to run the compiler for the different compilers that we specified. So in this case, we specified for GCC, and we specified for ARM compiler for embedded, and then it's going to compile both those applications and then make them available for the particular systems that we did. Okay, so the processing is all done now. So what you'll see happen is the compiler was invoked and compiled our FP Multiply for the Cortex M0 Plus. You have the compilation logs here you can download, and then it actually ran it on the fast model system, which is a functional simulation of the M0 Plus hardware system, and check that it all works fine. So that way we don't end up trying to simulate something that doesn't function properly. And you can download those by clicking on the different logs and studying those details. So, after that, now we have the custom benchmark is uploaded into IP Explorer, and it's ready to go. Okay, so let's go back to the simulation screen. And make sure our project is selected, and then we'll select the M0 Plus here. Okay, so now if we look on the My Uploads tab and we open that up, you'll see we have two new software applications here. So we've got the FP Multiply for the ARM compiler for embedded and the GCC version of that. And then we can select that. And then we can add that run to the simulation. So push add run to simulation. That will add the ARM compiler version that's in our queue. And then we can scroll down and do the other one, which is the GCC version. We can add that to the simulation. And then we can start those simulations. Okay, so now I'm on the simulation artifact screen, and you can see the progress of the simulations that are running. So it'll go through a sequence of initializing the simulation, preparing the software, and then running the simulation itself. And then when it's all done, we'll have the results that we can look at there. Okay, the simulations are running now. So most likely, if you have longer simulations, they're going to take longer than this one. So you can just leave them there and maybe check back and confirm the status. This one takes only a few minutes to run. Okay, simulations are all done now. So both compilers are done. So we can click view results. And then this will show us the results screen. So I won't spend tons of time on the results screen, but it's essentially showing you how many cycles were taken, some details about the systems and so on. And you can scroll down through those. Different kind of bus activity, which is happening, how many cycles were going on. And then the right side is where you see the simulation logs. So it'll tell you each section of the benchmark, how long it took. And you can have a look at those outputs. The fast model will be the functional simulation that's happening. You can look at the tab, and you can download the log files for those as well. You even see the print statement here. We did that floating point multiply. The values are there. So that's essentially how you can go through the loop. And I think you saw the whole thing now. To download the template with all the software, we created an application, we uploaded that application, and then we ran it in IP Explorer, and we could see the simulation results. Okay, so another thing you might want to do is change the systems that we're targeting. So that's probably the next important thing to learn is how to do that. So we saw in our software JSON file here that we were just targeting the M0 plus system. And what if we wanted to check another one? So maybe we decided the floating point multiply was too slow on M0 plus, and we need something with some floating point hardware support that we could run a little faster. So that's what you can change here. So the question is, what do we put here, right? So what are the choices? So the key is to look into the systems directory and see what the possible systems are. So if I open that, let's say we want to try something with more performance, like a Cortex M7. So you'll see here there's an M7X1-AXI4. That's actually the string that you would put in here. So if I put M7X1-AXI4, I could target the Cortex M7 hardware system. Now, maybe we want to try a second one. So you can use multiple of these separated by a comma. So maybe we also want to try the M55 system. So maybe we'll put in M55X1-AXI4, like that. So you'll see the different systems on the left side. So we can take this one, M55X1-AXI4. Actually, don't put a 5, let's put a 4. Okay, so if we save that, then that will give us two other systems that we want to target. So if we go back into the benchmark package, and then we look at our cheat sheet back on GitHub, you'll see when we build the application, the name of the benchmark is there. We haven't changed that, but we changed the name of the system. So we can test a compilation using that one. So let's copy that and then come back here. And so this time, let's see if we can compile the same application for M7X1-AXI4 using GCC. And that one goes through fine. So we got some warnings in the code, but it finishes and assembles that. So if we have those, then we could repack the tar file, we could send that back up, and then we could run those systems again and see how that goes. So those are probably some of the main features that you'll need. Really, the rest of it is learning kind of how to navigate the template here with the different benchmarks, the software tree, and how to insert that into your benchmark, and then how to build. So probably you might want to have a look around the makefile and see how to add extra source code, change some of the switches, and figure out how that works. And that's really going to be your main thing. So the key to it really is this line here. So from the makefile, there's an include pointing over to the system that we're trying to simulate, right? So you see under the systems directory, and then the name of the system, which is the thing we passed in, and then makefile system. So if we would navigate back over to the source directory, let's just take the M55, we have that one open, and then we can go down into it and find makefile system. You'll see here that there's going to be things that are more specific for that particular hardware system. So you'll see things like the architecture version here is ARM v8.1M main, and then you'll see the source that goes into it. So if you need to look deeper into how the compilation works, that's a good place to go, is just go to one of the applications, start from the makefile and trace your way back in. And then you'll see all the startup code that initializes the cache and the floating point, some of the peripheral code to help support the print statements and the startup and so on. So hopefully that gives you a good idea how to work with the custom software package, how you can add benchmarks to it, how you can build them locally on your machine, upload into ARM IP Explorer, and see the simulation results. So we'll wrap up there. Thanks for joining today's session about using the simulation feature about ARM IP Explorer. We hope you find it useful and you're able to run some of your own benchmarks and do some performance analysis using ARM processors.